Welcome to our session on Advanced Placement Statistics. Today we are discussing Topic 2.2, Summary Statistics for Two Categorical Variables. Today, we are diving into how we analyze the relationship between two categorical variables using two-way tables. Our learning objectives are to 1. Calculate joint, marginal, and conditional relative frequencies. 2. Compare distributions to look for associations. And 3. Justify claims using summary statistics. By the end of this video, you will be able to take a raw table of data and turn it into meaningful percentages that tell a story about how two variables interact. To begin, we need a way to organize our data. When we have two categorical variables, we use a two-way table, also known as a contingency table. Our objective is to calculate joint and marginal relative frequencies. Let's look at an example. Suppose we surveyed 100 students about their preferred superpower, the ability to fly or the ability to be invisible. We also recorded their grade level, underclassmen or upperclassmen. First, we need the totals. We will calculate the row totals, the column totals, and finally the grand total. The first statistic we will calculate is the joint relative frequency. This tells us what proportion of the entire group falls into a specific combination of categories. The formula is the cell frequency divided by the grand total. Let's highlight the cell for underclassmen who prefer to fly, which is 30. 30 divided by 100 equals 0.30, or 30%. So, 30% of all students surveyed are underclassmen who want to fly. Next, we have marginal relative frequencies. These look at just one variable at a time, using the margins of our table. We divide the row or column totals by the grand total. For example, looking at the column total for flying, we see 40. 40 divided by 100 equals 0.40. This means 40% of all students, regardless of grade, prefer flying. If we look at the row total for upperclassmen, we have 50. 50 divided by 100 equals 0.50. And 50% of our total sample are upperclassmen. While joint and marginal frequencies give us a big picture view, we often want to zoom in on a specific group. This is where we use conditional relative frequencies. Our objective is to calculate and interpret conditional relative frequencies. A conditional relative frequency restricts our focus to a single row or a single column. We are asking, given that someone is in category A, what is the probability they are also in category B? Let's calculate the conditional relative frequency of preferring flight, given that the student is an underclassman. Because we are given that they are underclassmen, our denominator is no longer the grand total of 100. It is the row total for underclassmen, which is 50. 30 divided by 50 equals 0.60, or 60%. So, 60% of underclassmen prefer to fly. Now, let's look at the same preference for upperclassmen. 10 divided by 50 equals 0.20, or 20%. Only 20% of upperclassmen prefer to fly. Notice the difference, 60% versus 20%. When we compare these conditional relative frequencies, we start to see how the two variables, grade level and superpower choice, might be related. We've successfully calculated statistics by restricting our focus to specific levels of a variable. Now that we can calculate these percentages, we use them to answer a major question in statistics. Is there an association between these two variables? Our objective is to compare distributions for evidence of association. An association exists if knowing the value of one variable helps us predict the value of the other. If the conditionally relative frequencies are different across categories, that is evidence of an association. Take a look at these two distributions. For underclassmen, 60% prefer fly and 40% prefer invisible. For upperclassmen, 20% prefer fly and 80% prefer invisible. If there were no association, we would expect the percentages to be roughly the same regardless of grade level. For example, if both groups had 40% preferring flight, we would say superpower preference is independent of grade level. Visualizing this with a segmented bar chart makes the difference striking. The slices of the bars do not line up. Because 60% of underclassmen prefer flying compared to only 20% of upperclassmen, grade level does seem to influence superpower choice. In AP statistics, when you see these differing proportions, you have found evidence of an association. We can conclude that, in this sample, underclassmen are more likely to prefer flying than upperclassmen. The final step is learning how to justify a claim. In your exams and projects, it is not enough to say they look different. You must use the summary statistics as evidence. Let's practice justifying a claim based on our data. Suppose someone claims that there is no relationship between age and the desire for invisibility. To refute this claim, we provide a comparison of specific percentages. We would write, the claim is incorrect. There appears to be an association because the conditional relative frequency of preferring invisibility is much higher for upperclassmen at 80% than it is for underclassmen at 40%. Key takeaway: always use specific numbers and labels in your justification. Remember, statistics is about more than just math. It is about context. Always mention the variables, in this case grade level and superpower, to make your argument complete. Let's summarize. Joint relative frequency is the cell divided by the grand total. Marginal relative frequency is the row or column total divided by the grand total. Conditional relative frequency is the cell divided by its row or column total. And remember, different conditional distributions indicate an association. You have now mastered the basics of two-way table analysis. You can calculate the key statistics, compare them to identify associations, and justify your findings with data. Great job!